Hello guys. Last class we discussed about the various forces and angles that is present on a single point cutting tool while cutting material from a workpiece. So today we will discuss about Merchant's circle diagram. Merchant's circle diagram is a circle in which we can represent all the forces and angles in a single diagram. Okay. So first of all we have to know the cutting FC and FT, the tangential cutting force and the thrust force. So FC and FC is determined by force dynamometers. First of all, I will say what is a dynamometer. A dynamometer is an instrument which is used to record or measure the forces acting on a single point cutting tool. So it can be resolved in planes only, but any other force components have to be found out by ourselves. And also I will introduce some of the angles, that is alpha is the rake angle, and the second one is shear angle. Here it is written as F. I'm sorry, that was a printing mistake. That is phi, and it can also be obtained from the chip reduction coefficient. Actually we don't want to study the details about chip reduction coefficient. You have to just know about alpha. Okay, now just forget about F and shear angle and all that. Now from from the Merchant circle diagram we can find Fs, shear force, and Fn, normal to shear force, from Merchant circle diagram. Okay, so this is the Merchant circle diagram. I will explain the methods to draw the Merchant's circle diagram step by step. First of all, set up XY axis labeled with the forces, like just set the origin like this point. This is the point where it is the origin. See here, this is the origin. All the forces originates from this point. This is the cutting point. Okay, so first of all fix a point as origin, and from origin draw the x component FC. See, this is the x component. Sorry, this is the x component. This is the x component and this is the y component. Okay, just draw the FC and FT. As you know that we can have the values from the dynamometers, we will write this. You can just draw these lines, and now the next thing is to have the resultant of FC and FT. You can find out by triangle's law. That is, simply you can draw three lines. See here, you can just simply write two lines, and this is the resultant. Okay, now fix a point at the center of this line. Okay, this resultant line, and as the center please draw a circle like this. You can draw a circle like this, as fixing R at the center of the R, as and the one of the distance as radius. You can draw the circle. Okay, so these are the steps. I will just read out the steps. Locate, set up XY axis labeled with forces and the origin in the center of the page. The cutting force FC is drawn horizontally and tangential force FT is drawn vertically. See that already already we have done. And now locate the center of R, that is the resultant of FC and FT. See, this is the second step, and if everything is done correctly, the heads and tails of all three vectors will lie on this circle. See, head and tails means this point. Okay, one of the point is that, and the another one is this and this. All the cutting heads and tails will lie in the same circle. Okay, and now the next step is draw in the cutting tool in the upper hand right quadrant, taking care to draw the correct angle alpha from the vertical axis. See, you can just see, this is the line, and from this point we can draw the vertical axis, and you can draw the angle alpha. Okay, this is the vertical axis, and that dotted line is the vertical axis, and you can draw alpha. Okay, so we have drawn the angle alpha from the vertical axis, and extend the line that is cutting face of the tool, and through the line, this is now the friction vector F that you can see in the figure. See here, you have already drawn alpha. Okay, now extend this one until it touches one of the point in the circle. Okay, one of the point in the circle. So this line is extend, and that is F. Okay, now join this line with this point, we will get N, normal vector. Okay, now I will read out the sentence. Extend that line, that is cutting face of the tool, and at the same break angle through the circle. This now gives the friction vector. A line can now be drawn from the head of the friction vector, and that is, and we have already done that, to the head of the resultant vector R. This gives the normal vector, and also add a friction angle between vectors R and N, that we can measure from that figure. Therefore mathematically R is equal to Fc plus Ft, that is equal to F plus N. Okay, now in the next step, draw the feed thickness line. Draw the feed thickness line parallel to the horizontal axis. Next, draw a chip thickness line parallel to the tool cutting face. That is, first you have to draw a line, thick line like this one, and the next line is from the chip. See here you can just draw a line from here also. Okay, where you can just simply add that this line will touch one of the point in the circle. Okay, that you can just simply draw like this chip thickness line. Okay, and also here is the another chip thickness line, and simply connect these two lines and you will get Fs, that is shear force. Here it is Fs, and you can get Fs. Okay, so I will read that once more. Draw a feed thickness line parallel to the horizontal axis. Next, draw a chip thickness line parallel to tool cutting face. Draw a vector from the origin towards the intersection of two chip lines, stopping the circle. See, this is the way to get shear force vector. Okay, and also we can measure the force angle between Fs and Fc. See, Fs and Fc. This is Fs and this is Fc, and this is the shear angle. Okay, so that is the shear force angle. Now finally add the shear force normal Fn from the head of Fs. Fs see, this is the Fn. From Fs you can draw a normal until this point, so that we will get the normal force Fn. Okay, so we have got our normal force Fn. This is the last step. So we have drawn all the curves. One Fn, that is perpendicular to the shear force. First of all, we have drawn Fc and Ft, and next we have found out the resultant, and from the tool face we have drawn F, and to the F, perpendicular to F, we have drawn normal N. Okay, this is the normal N. I will just show like the line like this. So we have found all the lines. Now you simply measure all other lines, and also the angles beta, that is beta angle, and theta is the shear force angle, and alpha already you have know the angle of rake. So this is the method to locate all the angles and lines of forces, and this is the way to draw a merchant circle diagram. Thank you.